One of the most popular kinds of machine learning is called supervised learning. But what does that have to do with the Titanic and cats and buses and hand-drawn numbers? Well, because supervised learning uses training data that is labeled. And if we want to train it on cats, we need each cat to be labeled as a cat. If we want our self-driving car to recognize buses, we need images of buses labeled as bus. And similarly, if we want to recognize handwritten digits, they need to be labeled. How do we get a database of labeled buses? Well, you have done that. You've contributed to it every time you go through one of the CAPTCHA processes to access a website. So here's one where you have to click on 3 buses. You have just labeled that data set for Google. And JN's quote here kind of sums it up. It finally dawned on me that Google is using this info to machine train its self-driving cars. Wow. So how is this data used in a supervised learning model? Well, to the left, we see a database of labeled observations. So maybe we have 500,000 labeled vehicles. So there's bus, car, bicycle, truck. And out of those, we take a big chunk to use as the training set. So somewhere between 65 and 85% of our data is used to train our machine learner model. So we work with that to try to maximize the accuracy without doing something called overfitting. Once that's done, then we use the test set, which is what's left of our data set that the machine learning model has not yet seen. And that is fed into exactly the same model to see how well it can recognize the brand new stuff. Typically, it's a little less accurate than the training set. But the big question, one of the questions, is it accurate enough? 87, 85% is accurate enough to predict whether an incoming freshman will graduate. It's not good enough for your self-driving car to look at that big yellow thing in front of you and say, is that a bus? So where did the Titanic come from? Didn't that sink? Well, yes, but we happen to have a database of all of the passengers and information about each one of them, their age, their name, and what kind of accommodations they were in. Were they wealthy with first class, those in blue in our cross-section? Or were they third class, the immigrants kind of jammed together far away from the center of the ship? Notice the lifeboats are where that big red arrow are. And what color stateroom, what color cabin is close to that? Could we create a machine learning algorithm to use the Titanic passenger data to predict which ones may have lived and died? How about those numbers? How about reading handwritten digits? Well, this is a real check from George Washington, the real George Washington, and there are a number of instances where he has handwritten with his quill pen handwritten digits. So his 6s look pretty good. The 2, the 9 looks like a G. That 5 and 7 are kind of shaky. Can a machine learn to recognize handwritten digits? Well, look at the variety of them. How could it possibly do that? Well, first we would need to digitize each handwritten digit. And in this case, they're digitized 28 by 28 pixels with 4 levels of gray. And then they have to be labeled, every one of them. And here are the first 100 digitized numbers with their labels. So this particular data set has 70,000 images of labeled handwritten digits, totaling over 11 million bits of data that has to be processed. Does that seem like a lot? Well, how about today? So in 2019, Google worked on a medical project getting patient data that amounted to 64 billion data points. And those were used to create a machine learning model to predict the medical outcomes of hospital patients. The predictions were classified into categories, such as getting better, dying in 2 days, something like that. So the output of a supervised machine learning model is either a regression model, which we would use if there are continuous values like height, weight, miles per gallon. Our example here with women's weight and height. Imagine a detective at a crime scene finding a woman's footprint in soft mud. Based on how deep the impression is, he could estimate the woman's weight, and using the regression line, give an estimate of how tall she might be. The other mode is a classification model, where, like the buses, we classify data into particular categories. So this is a truck or a bicycle. It's not like 1.5. There are no decimals. It's either this or it's that. The Titanic passengers either lived or died. It wasn't the night of the swimming dead. Or it's a digit like 0, 1, and so on. So to reflect, supervised learning requires labeled data. And that data set is then split into a training set through which the machine learning model learns, and then a test set to see, is it effective learning? The supervised learning model can predict a value using the regression model or a category using classification. So that's an introduction to supervised learning.